Have we just witnessed the end of one of astronomy's most exciting mysteries, or the beginning of something even bigger? When a glowing object streaked through the darkness of space earlier this year, it didn't take long before speculation exploded across scientific circles and online communities alike. Could this be another interstellar visitor? Or, as some dared to imagine, a piece of alien technology silently passing through our solar system? At the heart of the storm stood a bold theory from Harvard astrophysicist Avi Loeb, who suggested that this visitor, officially named 3I/Atlas, might not be an ordinary comet at all. His idea, perhaps it was something artificial, deliberately directed through space by a distant civilization. But just as the debate reached fever pitch, NASA stepped in. Armed with high-resolution telescope data and chemical analyses, the agency released a detailed explanation that, according to them, ends the speculation once and for all. Yet the real story of 3I/Atlas isn't just about whether it's alien or not. It's about how one small speck of ice and dust could rewrite what we know about the universe beyond our solar system. So what exactly did NASA find? Why did scientists even consider the alien possibility? And what secrets does this mysterious traveler hold about other worlds far beyond our own? Let's dive deep into the cosmic mystery of 3I/Atlas, the discovery that sparked global curiosity. It all began on July 1st, when astronomers operating the Atlas telescope in Chile noticed a faint, fast-moving glow sweeping across the night sky. At first glance, it seemed like countless other transient objects that telescopes pick up each year, but something didn't quite fit. Initial calculations revealed that this body wasn't following the familiar looping orbit of planets, asteroids, or comets tied to the sun's gravity. Instead, it was on a hyperbolic trajectory, a path so open-ended that it could only mean one thing. It came from beyond our solar system. That made 3I/Atlas something extraordinarily rare, only the third known interstellar visitor ever detected by humanity. Before it, there were only two: the enigmatic Oumuamua, which baffled scientists in 2017, and the more typical Comet 2I/Borisov in 2019. But what made this third interstellar object so intriguing wasn't just its speed or shape. It was the unusual behavior that followed. A comet or something else? According to data from the Hubble Space Telescope, the core of 3I/Atlas measures somewhere between 0.3 and 5.6 kilometers across, small in cosmic terms, yet racing through space at more than 200,000 kilometers per hour. For most astronomers, that alone made it a dream discovery. Studying such an object could offer unprecedented insight into how comets and planets form in distant star systems. But for others, the strangeness of its motion was too hard to ignore. Enter Avi Loeb. Known for his daring interpretations of cosmic phenomena, Loeb once proposed that Oumuamua could be an alien-made solar sail, a fragment of technology from another civilization. When he turned his attention to 3I/Atlas, he noticed features that, to him, raised similar questions. For one, the object didn't initially display a clear cometary tail, something most icy visitors form when approaching sunlight. Its trajectory, too, appeared statistically improbable, passing unusually close to Mars, Venus, and Jupiter. Loeb calculated that the odds of this pattern happening by chance were around 0.005%, almost impossible by random cosmic motion alone. That led him to ask a provocative question. Could 3I/Atlas have been deliberately steered? The theory that divided scientists. Loeb clarified that he wasn't declaring 3I/Atlas a proven alien spacecraft. Instead, he presented it as a thought experiment, an intellectual challenge to push science to stay open-minded about extraordinary possibilities. However, the public seized upon the alien angle instantly. Headlines flared across the internet, echoing the same fascination that surrounded Oumuamua years before. Once again, the world was captivated by the idea that something from another star system might not just be natural debris, but evidence of intelligence. While speculation soared, NASA quietly began analyzing every fragment of available data, and what they found painted a far more grounded, yet equally fascinating picture. NASA's answer, a natural explanation, emerges. When NASA finally responded, their message was clear: 3I/Atlas behaves overwhelmingly like a comet. According to Tom Statler, one of NASA's leading scientists on the case, it has some interesting properties that are a little different from those of comets in our solar system, but it behaves like a comet. Therefore, the evidence overwhelmingly suggests that this object is a natural celestial body. Behind that simple statement lay an enormous amount of observation and analysis. Using a combination of Hubble, James Webb, and ground-based telescopes, NASA tracked the object as it approached the Sun, and something remarkable happened. 3I/Atlas, once thought to lack a tail, began to develop one. But this was no ordinary comet tail. The peculiar tail of 3I/Atlas. Typical comet tails are narrow and sharply defined, created as sunlight vaporizes icy material that streams away in a single direction. 3I/Atlas, on the other hand, unfurled a broad, fan-shaped tail, almost like a glowing banner. At first, this seemed like more evidence for something unnatural. But NASA's analysis revealed a fascinating natural explanation: outgassing across the entire surface and an unusually high concentration of carbon dioxide, CO2, in its icy shell. Spectral readings showed that, unlike comets in our solar system, which usually contain about 10 times more water than carbon dioxide, 3I/Atlas had the opposite ratio. Its ice was dominated by CO2, indicating that it formed in a place far colder than anywhere in our planetary neighborhood. In those frigid reaches of space, carbon dioxide remains frozen while water does not, leading to a vastly different chemical makeup. As 3I/Atlas neared the Sun, its frozen CO2 began to sublimate, turning directly from solid to gas, creating that wide, diffused tail. This process also caused an unusual polarization of light, a specific pattern in the way sunlight reflected off its dust grains. The fine, widely scattered dust particles made light oscillate more strongly in certain directions, giving 3I/Atlas a reflection signature unlike any local comet. In short, everything strange about 3I/Atlas could be explained not by technology, but by the natural diversity of the cosmos. What 3I/Atlas teaches us about the universe. The implications of these findings go far beyond disproving an alien theory. For scientists, 3I/Atlas represents a pristine sample of interstellar material, matter that formed around another star billions of years ago and remained untouched ever since. Every interstellar comet is like a time capsule. Its chemical fingerprints tell us about the conditions of the system it came from, how cold it was, what elements were available, and what kind of star it orbited. The dominance of carbon dioxide in 3I/Atlas suggests it originated in an extremely distant, icy region, possibly in the thick disk of the Milky Way, where ancient, slow-moving stars reside. That could make this comet over 7 billion years old, predating even our Sun. Imagine that, a fragment of ice and dust born before our solar system existed, traveling for eons through the interstellar void before arriving here, and now, within reach of our telescopes. Such objects help scientists compare how planetary systems form under different conditions. By studying their orbits, composition, and dust patterns, astronomers can determine whether our solar system's evolution is typical or a cosmic exception. The broader lesson in the debate. The story of 3I/Atlas also serves as a reminder of how science evolves. On one side, thinkers like Loeb challenge orthodoxy and dare to ask bold questions. On the other, institutions like NASA ground those questions in observation and evidence. It's this tension between imagination and data that drives discovery forward. Speculation fuels curiosity, but evidence delivers truth. NASA's conclusion doesn't make 3I/Atlas any less extraordinary. In fact, it underscores how breathtakingly diverse the universe truly is. What once looked alien turns out to be a natural expression of cosmic complexity, proof that nature's creativity often surpasses anything we can imagine. A universe still full of mysteries. The case of 3I/Atlas may be settled, but it opens the door to an even larger mystery. How many more interstellar travelers are out there? Astronomers believe millions of such objects drift silently through the galaxy, remnants of distant worlds, each carrying the secrets of its birthplace. Every time one crosses our path, we get a fleeting glimpse into another star's past, and perhaps another civilization's neighborhood. So while 3i/Atlas might not be an alien spacecraft, it's something arguably more profound, a tangible piece of another world. It connects us, across billions of years and light years, to places we may never visit but can still understand through science. And perhaps that's the real magic of discoveries like this. They remind us that even in the absence of aliens, the universe itself remains the greatest mystery of all. So, has the speculation ended? For now, yes. But the questions it raised, about how we search for meaning among the stars, about what's possible in the vast silence of space, those are far from over. Because every time we look up and spot a faint streak of light racing through the cosmos, we can't help but wonder, what else is out there, still waiting to be found?